Hi, my name is Natalie Urson, and today I'm going to be explaining the experiment that my physics group did titled How Does the Angle of a Ramp Affect the Maximum Velocity of an IOLAB Sensor Rolling Down It? We did this for the University of Massachusetts Amherst Winter Session 2022 to 2023 for the Introductory Physics Lab. So first we got to know the IOLAB sensors before starting our experiment. The first one up was the accelerometer sensor, which measures the acceleration of the IOLAB device in the X, Y, and Z directions. It provides us with the change in velocity per time with units of meters per second squared, as is typical with any acceleration. And this can be a slightly problematic sensor because it cannot determine whether or not an object is in free fall versus at rest, which causes it to give inaccurate readings at times. Next up is the force sensor, which reflects an equivalent value to the force that is acting on the spring and eye hook in the bottom of the IOLAB device in the Y direction. We did not use the sensor for our experiment. And then the third one was the wheel sensor, which we did use. It measures the position, velocity, and acceleration in the Y direction as it is labeled on the IOLAB device. However, for this experiment, we defined it in the X direction. And then collecting the data from the sensors, the IOLAB device actually connects to a USB receiver to transmit real-time data to a compatible computer with the IOLAB program installed. And the force and wheel sensors have to be physically moved to generate data. So for the force sensor, it's being physically pulled on or pushed on, and then for the wheel, it has to be turned. So for our experiment, we were interested in measuring the maximum velocity of the IOLAB device, which we termed the cart. And this was measured by the wheel sensor. We thought that, this could vary depending on what angle that the ramp is placed on. And we used a foam poster board with 3 different heights in order to investigate our hypotheses. Our hypotheses were that the angle of the ramp will not impact the maximum velocity of the cart. So that was our null hypothesis. Our first hypothesis was that increasing the angle of the ramp will increase the maximum velocity of the cart. And our second hypothesis was that increasing the angle of the ramp will decrease the maximum velocity of the cart. So like I said, we're going to be having the cart. We had it roll down 3 ramps of different heights in order to see how that would affect its maximum velocity. We placed a large, heavy backstop at the bottom of the ramp in order to maintain the position of the ramp for consistent and accurate measurements and to stop the cart when it got to the bottom of the ramp. Each of the 3 ramp heights had 3 different trials using the wheel sensor to obtain the velocity graphs per time for each of those ramp heights. And then we did take that data and further analyze it. So we had a large ramp, a medium ramp, a small ramp, and we calculated the angles of those ramps as well. And then we did make some assumptions for this. Firstly, the ramp would remain stationary during the experiment. Gravity is constant and will remain constant, and that the IOLAB readings we receive from our experiment are accurate. The development of these assumptions was critical to the development of this experiment because a heavy backstop was implemented at the bottom of the ramp in order to prevent the ramp from moving. And then that would just ensure that it was consistent length of a ramp between trials and then also during the trial so that the cart was not moving the ramp. And we'll be discussing more about those assumptions later on. So the data that we collected was using the wheel sensor, as I previously mentioned. We plotted these data on IOLAB to receive the below graphs. And then we also had the maximum velocity, which is highlighted by these vertical lines here. And then the maximum velocity for the 3 trials for each height were averaged to find the average maximum velocity. And then, so for the small ramp, trials 1, 2, and 3 were averaged to give a 0.641 meters per second average maximum velocity. For the medium ramp, it was 0.969 meters per second. And then for the large ramp, it was 1.287 meters per second. And then you can also see here the different angles that the 3 ramps were placed at, which correspond to their heights. And then for our analysis section, we delved in a bit deeper to our data points. So the data shows that the angle of the ramp, as it increased, the average maximum velocity also increased, which supports hypothesis 1. This is because as theta increases, so does the horizontal component of the force of gravity. And as I said, this is in the X direction, which is as we defined it to be the surface of the ramp being that X direction. There are some factors and limitations which impacted the accuracy for these measurements. First of all, the calibration of the IOLAB sensor. Secondly, the rigidity of the lamp ramp, excuse me, and the stationary nature of the ramp. So the IOLAB sensors were calibrated prior to this experiment. However, whether this calibration was perfect or whether or not it remained perfect throughout the duration of the experiment is unknown and could potentially contribute experimental error. The ramp was also made out of stiff foam board and it did not visibly lose rigidity during the experiment. However, it is possible and it may have limited the accuracy of the measurements taken. So, for example, if the cart was pushing down on the ramp and it buckled a little bit, just not enough to be seen. And then additionally, the heavy backstop appeared to be firmly in place to hold the ramp at that consistent angle, but it may have moved during the experiment, causing a potential inaccuracy of the angle or length of the ramp. And there also may have been human error with hitting the record data button on the IOLAB program at the same time as releasing the cart. However, this would not have affected the maximum velocity reading recorded as it was dropped from the same point every time, the very top of the IOLAB matching up with the top of the ramp. So regardless of when the actual button was pressed to record the data, the maximum would appear the same.